Installing the Elon box and the DC box. Now that our solar panels are installed on the roof and the cables are fed through from the roof, we're going to connect the cables to the fuse and DC circuit breaker. The red cable, which means positive, running from the solar panels, must be fed through this grey fuse box, which will protect against excessive current and prevent short circuits. And then your black or negative is connected to the other side of the breaker. First, connect the green and yellow earth cable to the earth bus bar to prevent shocks. And then you connect another red positive cable through to the breaker. And then your black or negative is connected to the other side of the breaker. Now the panels are connected. Now we can go back to the roof and connect the positive side of the male and the female that runs to the DC box. The panels are now live and sending current. Next we connect the DC side of the Elon unit to the breaker. Connect the green and yellow earth cable to the earth bus bar to prevent shocks. And then fit the red and black cables, taking care to connect red to red and black to black, as seen. And then connect the wires into the Elon box. You will see on the Elon box the positive and negative solar input terminals are marked, and the negative sign is marked with a 0. So we connect the black wire to that terminal, and the red cable we connected to the positive terminal, which has a plus sign, to the right of the negative terminal. Then we take these two cables, red and black, connect one end to the thermostat terminals on the Elon unit, and the other end to the thermostat itself. As you can see, your element cables have an earth wire attached, and that must also be connected. And now our Elon box is wired up. Next, on the AC side, we first switch off the isolator, and now we're going to disconnect the AC wires from the thermostat. Step 1 is to loosen the element cover. And then we use our tester, we switch it to AC volts mode, and just to make sure that the isolator is working, we test to see if there's any power connected to the thermostat. The tester shows no charge, which means there is no voltage on the element, so we can safely work on it. We unscrew and disconnect the cables, and we can remove the wires from the live terminals and connect them to the mains power terminals of your Elon unit. As you can see, there are now 3 earth connections, the main incoming earth, another one connected to the element, and the third one connected to the panels. Once all your wires are fitted, we will use our pair of long nose pliers to pull on each of the wires, just to ensure that all the wires are securely connected. If a wire is not fastened nicely, it will come out, in which case we will refit it and secure it properly. In many cases, installation problems are caused by a loose cable connection. Now we're going to pull out the thermostat and we're going to fit it into this green PC board. The board has a fuse inside it, so when your thermostat gets stuck, it will pop the fuse and then the Elon unit will stop powering the heater. So once our thermostat is fitted into the board, we can insert it into the element like this. Remember to ensure that the 2 pins are properly inserted into the element so that we don't make a hot connection. To double check this, turn the thermostat, and if the PC board doesn't turn with it, that means the board is securely fitted. Okay, so now we have 2 wires, the thermostat wire and the element wire, Note that the element wire has an earth wire attached to it, whereas the thermostat wire doesn't. Next, we will insert the two cables. The thermostat's wires don't need to be on live and neutral. In other words, they can be connected any way around because they're only feeding into a cutoff switch. Now we're going to connect the element wires and secure them. And now we can just connect our earth wire, and once our earth is fitted, we crimp it. Now all our wiring is connected. Again, we check that all the wires are securely connected, and then we're going to plug in the control dial into this port. Make sure that you seat it properly. You'll hear a click sound. And once that's done, we're going to turn the control dial to the solar only setting. And then we'll test the DC side of the system. So we switch our multimeter to the DC volts setting in order to test the voltage that's flowing from the panels. So we contact the positive and negative terminals, and if we get a reading, we will know that the panels are producing voltage. Next, we're going to activate the fuse and test the voltage again. Our live connection is going through the fuse and back into our breaker over here. So if we test at the breaker and we still have voltage, then we know that the fuse is working. If not, then the fuse is broken. Now we test the voltage on the top of the breaker, and if we still have voltage, then our loop is complete. Then we switch on our breaker, which will now start feeding power to our Elon box. If we test here and pick up voltage, then we know our breaker is working correctly. Next, we move down to our Elon box and test the voltage here. If we have voltage, then we know that the Elon will start receiving power from the DC side. Just make sure that your polarity is correct, because if we get a negative voltage reading here, then we know that our two wires need to be swapped around. So now we're going to switch on our AC isolator. Note that there is a 5-minute delay before the Elon will show red on your control dial. The green light on the solar only setting needs to start flashing, and then we can test our voltage on our element side to measure the voltage flowing from our panels. And if the element kicks in, there must be a drop on the voltage side. So if we test our voltage on DC, it must show 0 voltage. If we turn our thermostat to minimum temperature when it clicks, then the green light is going to be stable on our control dial. And then we can also test to make sure that the thermostat is also working correctly, in which case we will get a reading of between 11 and 14 DC volts on your multimeter. Once you've tested there, be sure to test at the Elon box 2, where on the thermostat terminals we will need to get the same voltage reading that showed on the thermostat, also between 11 and 14 DC volts. We can then switch the thermostat on again, and next we adjust the thermostat to the client's requirements, usually between 50 and 65 degrees Celsius. And then we'll see that our green light will start flashing again if your heater has not yet reached the required temperature. So that's how we test our DC side. Now we're going to test the AC side. So the 5-minute delay on the Elon box on the AC side should now be completed. So we'll need to see a red light showing on your control dial. And then if the mains is showing red, we need to turn the control dial all the way to mains, and our mains is then active. Next, we take our multimeter and switch it back to the AC volt setting. Then we test our AC voltage on the Elon, and we need to get a reading of between 230 and 240 volts. If our thermostat clicks in, the red light will start flashing, and then we can test the element for amps. A correct amps reading on a 3 kilowatt element is between 12 and 13 amps. On a 4 kilowatt element, the correct reading is about 18 amps. Now that we've finished commissioning the system, we can turn the Elon control dial to its number 3 setting. Number 3 means that the system will use solar during the day from early morning until late afternoon, and will top up with grid power at night. So now everything has been tested and we can start closing up the system, replacing the covers and screwing them in place. We've fitted our box horizontally, and this ensures that if our cabling is running vertically from the roof, any moisture that flows down will not seep into the box and cause damage to it. This way the moisture will stay inside the conduit. And now we have installed our Elon box and DC box.